Hello.
Hello.
Welcome to Infracoders number 31.
So, long time.
That's Matt. I'm David.
We're at Sportsbet. How's the view? It's pretty good. I think this is the best view we've had so far. So, Sportsbet getting the award for that, I guess. So, microphone. We've never had a microphone before. This is fancy. So Andrew, place your bets. Andrew from Sportsbet is just going to give his little 1-minute hello and introduce us.
Thanks, Paul. Hi guys, thank you. Firstly, thank you for all of you for actually coming down. We're actually Sportsbet's quite excited to have you all here. I think what you'll see through the talk a little bit later on from the Odyssey guys. We've had an interesting journey this year, kind of really how do we start doing infrastructure as code, continuous integration, everything like that. It's been quite a new journey for us. We do have a vested interest in actually bringing you here. We want to keep that journey going. We want to start to promote Sportsbet as actually being really one other sort of technology hub really within Melbourne. So we've got quite a new team, new staff. We're quite committed to growing that out. We see this as really a first step in actually starting to put Sportsbet really on the map. We do a lot of really good stuff here. We're just getting bigger and bigger. It's probably not something that everybody sort of understands how it works. I know for me, I've been here probably just this year, and it's been an interesting journey. And it's really a big sort of eye-opener as far as how the industry works and how essentially, we don't call it gambling, it's actually entertainment. So there's no gambling there at all. You know, it is really our mission as a whole is really to add excitement to life. And it is exciting, and it is something that and a lot of people actually enjoy. So it's actually quite a fast-paced environment, and there's a lot of challenges there. And I think it just all in all, I think the biggest thing and one of the big things that really sold me on the company was really just the quality of really the people that you have here. So when we have a good laugh, everybody's mucking around, but obviously we're just working as hard as possible to kind of keep everything going. So on that note, it's just really great to see you all here. I think hopefully we set a record for Infracoders, someone as far as people here. I think we are looking forward to doing this. Obviously this is the first one, so if we can do it again, we'll do it again. And then from there, and obviously we'll make it a bit easier to get into the building. But I think we're learning those things. So on that note, thank you. And if anybody wants to have a chat later on, feel free to grab me. And then moving forward, if you want to have a tour of the office and things like that, just give us a yell and we'll take you through. So enjoy the night.
So we actually need the mic. Can everyone hear?
I can't hear.
Thank you, Colin. Get your ears tested.
Can you introduce the first speaker, Dave, while I fiddle with this?
Yes. Now, I can't remember the title of your talk. It's quite a long one, so I'll leave that to you. But this is Norman Tudor.
Hey. Right. Why did this turn off?
Is it Linux?
No. Oh. Yeah, suck it up, Princess. Right. My talk is titled Packer and Vagrant on Rails. You'll find out why in a minute. This is me. Now, because this is so far from this, I've got a lot of this on one of these. Now, I could do this and this until I do this and this, but this does not go so well with this, mainly due to this, and this. So I decided to see if I could do without this and try to do this with this on this. Thank you. And I will give credit to Burin for the title of my talk. Thanks, Burin. So this is about Packer and Vagrant. It's a bit about what do they look like, and what does that really mean? What then after you know the Packer and Vagrant is? To give you some idea, let's begin with a simple scenario, okay? Simple scenario is someone asks you to build a server. So when you build a server, you create you create a virtual machine. And then you do some base install. This is where you think about your OS installer. You set your host name, locale, layout, users, this layout, packages, all that sort of stuff. Then you can go into all the puppety stuff, Puppet and Ansible and Chef, scripting and everything else. A couple of manual things if you want to do that sort of thing. Then you operate the server, you'll do some updates, you'll do some config, you turn it off, you suspend it, you boot it up again. And eventually you get tired of it and you flush the damn thing down the toilet. Right? Then, woohoo, you've got yourself a server. You built something that works. And you think, oh, why are you working on this thing? You think, oh, I like this one, I think I'll clone it. And you go and make a whole pile of other machines because it's virtualization. Cloning is really easy. So you clone this thing in your environment. And after a little while, you've got one of those and you go, oh, I like that one. I think I might go clone that one again and make a new server. And after a little while of mucking around with that one, you go, I like that one a bit more. I'll clone that one once or twice or a whole bunch of times. And then that's fantastic. You've got a whole server room full of gear. All the servers are up and running, all clones of each other, everything's working really, really well. Until some idiot comes along with an update for a package that doesn't update really well, something that requires a significant change in your infrastructure stack, or an operating system update, CentOS 7, for example, and it all gets really hard. And then you look at your server room and you eventually become somewhat disillusioned with the decisions that you've made. That's okay. Keep calm, automate all the things. So, what do you do now? You go and you build an image. You build an image by, again, you start with a server. You create the server, you give it RAM, storage, devices, whatever else. You then do your base install, operating system, layout. You do your Puppet, Ansible, Chef, scripts. You don't do anything manual, you keep everything in your automation. And then you stick that thing in a box. You wrap it up, put it somewhere, because now you're going to build your server. The server is going to be something like this. You create your server somewhere, you clone that image, you open that box, crack it open, stick that sucker on there, and you've got yourself a running operating system. Then you might do some more scripting, your Ansible, Chef, Puppet, whatever it is that you want to do. You'll operate the box, you'll run it in the server room, you'll do whatever you need to do with it, and then again, eventually, you get tired of it and you flush it down the toilet. So, where does Packer and Vagrant fit into this simple picture? Like this. Packer will help you create that base image from nothing, from a known base install, or usually from an operating system disk, for example. It'll help you create the image that you want to deploy. Vagrant is the thing that will help you clone that image, create the virtual machine that you want to run, do all that configuration, manage the machine while it's in play, and then help you flush it. This is probably best shown to you with an example. Here's one I prepared earlier. This example will be Packer, and because it's running on my laptop, I'm going to use VirtualBox. I'm going to boot from an OS disk. I'm going to do CentOS. But for the provisioning, I'm going to put files on it from somewhere. I'm going to run some scripts. I might do some Puppet stuff as well. And as well as that, I do need to do some VirtualBox guest editions, because Vagrant's going to need those because it does things like shared folders and things. And I'm going to create a Vagrant box. As well as that, in Vagrant, again, I'm going to use VirtualBox. I'm going to clone this thing, do some additional provisioning in scripts, direct scripts running script files or whatever it is, and do some more puppet stuff, right? Now, the reason this is called Packer and Wagon on Rails is because I wanted to find out if I could do this stuff on my laptop on the train. I spend a lot of time on the train. On the train, I don't have internet access, which means if I'm going to play with this stuff, I can't rely on internet access. I have to do this stuff on my laptop in complete isolation. So, to get this thing set up, this is what I go through. You download Packer, you need to make sure that Packer is on your path. You download VirtualBox, you need to make sure the VirtualBox is on your path. You pick up the CentOS, ISO, and I use CentOS because the Ubuntu pre-seed is just awful. So let's have a look at what that's going to look like. When you run Packer, you give Packer a JSON file that describes the things that you want to build. The JSON file can contain more than one system description. So I'm just going to build my CentOS from the bin DVD, the basic layout from my basic JSON. So, here's what I did earlier. So, running Packer from the command line. The only time I'm going to touch the keyboard is here. So you can see that it is just there it is. Let's watch this. Packer has done this. Packer is now typing in the rest of the boot command to get this thing to boot and pick up a config file. Boots the image. Come on. Come on, you can. Come on. Then it starts going through all the config, right? It's doing all the stuff to, it provides all the stuff for your Kickstart file. It's configuring the network. It's going to be configuring all the packages. It's doing the installation media. I told it not to test the installation media because I don't care. How often is it going to break?
CRC, I don't know. ISO.
Yeah, sure.
What's that is your half-life?
Sorry?
What's that is your half-life?
Yeah, it's automation. I'll just go get another one, build a new disk, run it all over again. So, here it's running. Doing my disk layout. Yep.
And you prepare to start from an ISO that is from CentOS vagrant image.
I don't start from a CentOS vagrant image because that means I'm dependent on somebody else to provide me the CentOS vagrant image. I wanted to find out and demonstrate that you can start from nothing. This is the CentOS 6.5 ISO. So now it's doing the packages. So let's go back to this. Packer lets you describe what your machine is going to be. So this is going to be a VirtualBox ISO build. It's called this because I want it to be. I can tell it how much RAM I want. I can tell it how many CPUs I want. This is just to build my operating system. I told it to start it. So I've taken care of CPU, RAM, devices, and storage. Base operating system. You tell it what boot you're going to boot from. Here's my ISO. It's on my laptop. Here it says HTTP directory because down here, where it types in the command that you saw before, it says HTTP. Packer starts up a web server. It fills in the port number and the IP address, and it tells it where to go find the Kickstart file. You also tell it what you want to do with VirtualBox guest editions, so it can attach the ISO to your image. Now, because this is all in source code, here is my Kickstart file. I can do anything I like in my Kickstart file. Yeah, I'll set my password to, because I can, but you can do anything you want. Here is where I do the disk layout. These are the packages that I'm going to install. And this will reboot. Don't do the ask me for username, blah, blah, blah. I don't care. The next part where it configures the packages, which it might be up to. So still waiting for SSH. Still installing the packages. So when you go to the configure step, where you say, I want to go and do things after the operating system is installed. Excuse me. After the operating system is installed, you can say, run this script. These scripts that I've got here. Run this inline shell. Make a directory for me. Upload these files. Put these files from on my laptop onto my image. And then here, I can say for only this particular thing, for CentOS 6.4 and CentOS 6.5, because there's other stuff in my Packer file, do some specific Puppet stuff. I do Puppet because I love Puppet, but these are the things you can do. Then you can say, now I want to clean up. After I'm finished with the build, I want you to clean up. I want you to delete the IDE controller from the image, because I don't want an IDE controller on the image that I'm running out of Vagrant. And you can say, create me a Vagrant box once you're done. Once that is done, Packer will create for you an OVF file and a VMDK file. Unless, oh, in that case, in this case here, I get a CentOS 6.4 bin basic, because that's what my builder said, OVF or VMDK. Or, given that I've said do my post processes in Vagrant, it goes Packer box name builder, which is Vagrant, I think, and do the box. So I should end up with a file called Packer CentOS blah 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 virtualbox.box. This VirtualBox is now something that I can import into my Vagrant. That's my box. Let's have a quick look over here. Okay, now it's going through a reboot. Still haven't touched it. It's going through the reboot. And it will eventually start doing all the other stuff. Use the VirtualBox guest editions. It's going to build the VirtualBox guest editions because that's one of the commands I told it to run. If you don't want to do the VirtualBox guest edition, don't run the command. Don't do the ISO. I do want to do that because I'm going to use this thing in Vagrant. That will take a little while. Now, I keep talking about Vagrant. I'm using Packer to create a Vagrant box. Vagrant has some requirements. The requirements are that you create a Vagrant user. You need a user and you need some keys so that you can SSH to it without using the password. You can do that by shell provisioner or a file provisioner. They're two things that Packer allows you to do. Run a shell command, stuff all of your keys into your shell command and dump it out to a file, or pick up files and put it onto the machine. It also needs VirtualBox guest editions. So VirtualBox guest editions, it has direct support for VirtualBox guest editions as a URL, and then you run the shell provisioner to go and actually do the installation and building of VirtualBox. So, it's doing some more stuff here. It's now up to it's doing some Yum stuff. It's been doing some Yum util stuff. It's gone off and run off the screen. And now it's stopping the box, exporting it, and making the .box file. So here you can see it's starting to create the OVF file, and eventually it'll create that .box file. In addition to that, the prerequisites for VirtualBox guest editions, you have to put them somewhere. Somewhere you've got to install the things you need to run VirtualBox guest editions. How do you control that? You can stick them in the Kickstart file. You can stick them into a shell provisioner. You can stick them into anywhere you like, as long as they're done by the time the thing's built. You get to pick where they're going to go. You get to control it. You own all this stuff. So your source code looks like this. Here's your JSON file. Here in my source repository is a Kickstart file with this particular build. Here's my Puppet manifest. You need some modules and stuff if you want to do that stuff in there. These are the packages that I need to pre-stage because I want to do the stuff on the train. This is the thing that you have to do off the train. You've got to go and get these things yourself and put them on a laptop so that they can be used here. And there's a bunch of scripts down here that I need to run, like doing my Vagrant user stuff and doing my VirtualBox guest editions. This will take about another 4 minutes. Moving on. Now we get to Vagrant. If you want to run Vagrant on your laptop, these are the things you need to do. vagrantup.com, download the MSI. Yes, it's Windows. Suck it up, princess. You do the download the MSI, install the MSI, and make sure Vagrant is on your path. You've already done the VirtualBox then. Yep. Yeah, we'll get there. Yeah. So what I did forget to mention was each of those icons that I showed before, VirtualBox, boot from ISO, CentOS, Shell Provisioner, Puppet. Each of those can be replaced by something else, or there are other things that you can use. You can install from, you can run VMware Fusion on your desktop. It does support AWS. It does support OpenStack. I'm having some trouble at the moment with OpenStack on my laptop, but I won't get into that. So it does support a whole pile of other environments. You don't have to do VirtualBox, but this is what I need to do on the train. You can do VMware Fusion or VMware, is that on player? Or you can use Parallels on your well-installed Mac. It'll work. You can do that if you like. So you need your virtualization platform. And in this case, for Vagrant, you're also going to need SSH. Because with Vagrant, here we go. Let's go back to this. Now I'm finished. Here's my .docs file. This is now a Vagrant capable image file that I can now import into Vagrant and stand up a box from it. I can stand up a whole bunch of boxes from that one base image. So let's have a look at Vagrant. Vagrant, you do the same thing. You create your virtual machine. You specify CPU, RAM, storage, and everything else, which is what all this is about. Here I'm saying I want to attach my DVD ISO. Because I'm doing this stuff on the train, I don't have internet access, I can't do package installs from anywhere other than ISOs on my laptop, which means I have to attach this. I can attach the other DVD as well and configure all that stuff up so that my repositories are working from the ISO. I can do forwarded ports as well. So here is my CPU, RAM, storage, devices, and everything else. Then you clone an image. This is where you tell it what image you're going to clone. There's my box file. There's my host name. Because it already comes with an operating system, all I need to do now is do all the other things that I want to do from my base operating system. In this case, I'm going to use it to go and do something. I'm going to do some Vagrant Voodoo stuff in Puppet, and I'm going to do some other basic stuff in Puppet. In this case here, I'm saying for the CentOS box, I want to do this one. And in general, I want to do this one. So I can override them in whatever layer you want. And I can also say run a shell script. So this is just to demonstrate that I can run a shell script. I can run a shell script with commands. Off you go. So I have a Vagrant box. I've created my Vagrant box, and now I can stand one up. A Vagrant file contains references to a number of different servers that are in my single Vagrant file. So Vagrant up CentOS 6.4. This should work. So it doesn't have an image yet. Well, it can find the image. So it goes to find this box file, expands the box file, creates a virtual machine, talked about with the MAC addresses. Boots the machine. And if you look really carefully, see it just appeared over here. Here's the machine it's booting. Would have come up all by itself. You'll also notice back here that it's doing SSH port forwarding. Vagrant will go, look, port 22 is pretty much in use on your laptop. I'll forward it to another port and I'll tell you what it is. I can tell you what it is, but telling you what it is isn't really all that useful because you've got to go back and remember it, which is a bit of a pain in the neck. So, once it comes up, now it's running all my other bits. It's doing a shell provisioner. It's doing some puppet stuff in here. Now the box is ready. So the box is this one. Now, to log into the box, you say Vagrant SSH. Because your Vagrant file tells you what your box is, you don't have to remember the port number. It just goes, sure, I'll go and work that port number out for you because I know what box I just created. I know where to go and look for the port number. I know how to SSH. And now me. Here are my two DVDs that I've mounted. Because now I can do things like list installed, and it doesn't keep failing saying, I can't get out to the internet. Where's all your bits? I can now install anything I like. I've got a fully operational, standalone working environment on my laptop. In addition to that, because it's Vagrant, Vagrant does some nice things with shared volumes. So it'll automatically mount something on here inside my virtual machine that is shared between my VirtualBox and my desktop. So if I look at Vagrant, this should be vaguely familiar. Here is my box file that I just created. Here is the scripts, there's the packages, modules, that's mucking about, and basic JSON and all the other files that I need. So if I this file I touched in my VirtualBox, automatically shared directories. Everything's available. That means that I can get onto my Windows box or my desktop and go and muck about with stuff, create files, delete files, do all my stuff to do with source management inside on my laptop, on my desktop, and I've still got an operational working environment inside Vagrant. So I can, when I get tired of it, I can just delete it. Because it's automation, I can just delete it because I know I can just create another one. Vagrant up, I'll cut another one, and off we go. It's all done. The whole box is gone. Won't make much sense to you, but that Vagrant file used to turn up in here. One of the really cool things that I found out about Vagrant and Packer, guys at OpenStack have created a Vagrant stack where they give you a Vagrant file and you can stand up an entire OpenStack stack if you've got enough grunt on your laptop. So here is a control box, a network box, compute node, and a sender node. And all I did was download the Vagrant file, Vagrant up. I do this at home, but Vagrant up, and up it came. So the additional source that I put in is my Vagrant file and the Puppet stuff that I wanted to do for this particular provisioning. If you've got other scripts and stuff, you'll put them wherever you want. My point here, though, is all of this stuff is now under source control. Pick it up, check it in. Your infrastructure has become a source code problem. One of the interesting things that I was able to do with mucking about with this stuff was, for me, was to compare offline version with the online version. What happens when you want to do this stuff online as opposed to offline? What does it look like? If I'm going to build a packer box online as opposed to offline, how does it look different? There are only three real differences. The first one is, for offline, I need to pre-stage some packages. If you're online, you don't need to pre-stage those packages because you've got a live internet connection. You can just go and get the packages anytime you like. Managing the media, because I needed to do things like do all my proper installs. I had to configure my repository so that both of the DVDs were there, had to mount the media and configure the repositories to make sure that I could do Yum installs. Having seen the Packer and Vagrant stuff, though, that's all very well and good on your laptop, but what can you use it for? First thing that you can use it for is learning, right? You want to learn how to muck about Puppet, Ansible, Chef, Linux, Yum, anything you like. You can stand this stuff up on a laptop. This laptop is bigger than the last one, physically, but the last laptop I was playing on had 4 gig of RAM, and I could stand up almost 2 VMs with about 700 meg each, 2 VMs running at the same time. That was really useful. Ran out of grunt really fast, but I could do that. I could learn Puppet. I could muck about with this stuff, and you can do this stuff on train. The other thing you can do with Packer and Vagrant is operating system flavors. Your Packer file, your JSON file, allows you in a single place to describe more than one server. The idea of the JSON file, the Packer file, is to create equivalent or identical, probably not identical, equivalent machines. So you've got a machine that you're running out of AWS. Sometimes you run out of AWS, but on occasion you want to run the thing on CentOS on your desktop. You can do that. Your Packer file can describe all of that in one file with all the scripts that you need to make that work. So it allows you to have equivalent environments that are built out of the same Packer file that you can then hand over to somebody else. Personal test systems. One of the issues we have at the enterprise that I'm working in is general test systems. Personal test system. This allows you to create a test system on your desktop where you can do whatever testing you like. You stand it up and bring it down. Your team can then provide standardized test systems to each other. You've got a source control of the Packer and Vagrant files that you're going to need. And you can hand it around your team. Each of your team can then stand up a single file or a bunch of VMs that look identical every single time. Development test systems. You know, when QA needs machines to run on, especially in enterprise, how do you manage those? How are you building them at the moment? You're building them by hand, mucking about with them, and they're all slightly different, they all slightly don't work, and they're all slightly dirty. If you're using something like Packer and Vagrant, you can stand them up with automation, you can burn them down, bring them back, and they're all clean. Your CI system builds, your build engineers, your build agents that are running your builds, the continuous integration builds. You can build these things with continuous integration. You can build Packer and Vagrant boxes with automation. Automated tests. Imagine integrating this stuff with your automated tests. You've got someone writing code to create an environment for the machines where you're going to run, where you're going to be running your testing. You describe those, you check those in. The automated test run creates a machine where it's going to run, does your build, throws it onto the machine, does whatever testing it is, off it goes and destroys them at the end. Development infrastructure. This is a duplicate. Development infrastructure where you've got your build service, build agents. How many times have you gone, I need to build this thing on something, and I don't know how the last one was built. Does anybody know? Can anybody recreate the build agent that we had? No, yes. Automation. Production infrastructure. Yeah, this is a bit scary. You can use Packer Invasion to generate your production infrastructure. There are some organisations, you talk to Playout, Kevin, his production infrastructure is built with Packer. They're using Packer to create production instances that are uploaded onto AWS and deployed from there. They don't touch them, they don't fiddle with them, they just bring them out of their storage inside AWS and deploy them from. It also means something like an upgrade of your system. You don't upgrade your systems anymore. You built the first one out with automation, you change your automation, you build a new one, and you replace it. You treat your servers like cattle markets, which means you can finally stop curating your servers. Okay, questions. I'll start with two. Why aren't you doing this already? And who's up for a vagrant hack night? Yep.
Did the use of Vagrant and Packer make it any easier to deal with shell shock?
Sorry, with what?
Did the use of Packer and Vagrant make it any easier to deal with shell shock?
Shell shock. It can, because your updates.
You did not use it to make it easier with shell shock.
No, I didn't use this to make it easier to deal with shell shock. The environment that I'm working in doesn't lend itself to using. Well, so the commercial environment that I'm currently working in doesn't lend itself to doing that sort of thing. This is the stuff that I'm doing in my environment. Does anyone else have any information about being able to use Packer and Vagrant to rebuild their servers and deploy updates in production? Sorry? Yeah. Yeah.
So if I just put package it just
Yeah. So hand hacking stuff? Sure, go right ahead. Yeah, automated. What? How did you automate that? Puppet? Yeah. Puppet Master? Yeah. Yeah. So there are some things that you will probably do in your management environment. So things like your Puppet Master, you'll touch your Puppet Master, you'll add the thing to the Puppet Master catalog, and then Puppet Master will just go and distribute that everywhere. That's not really where you want to go and rebuild your server. It's part of your management operation. It's where you get things like a new operating system, something that doesn't update really nicely, something that doesn't have an upgrader, where you have to go and rebuild your base. Yeah. Any other questions?
We'll have time for one more because we've got another talk before the food comes, unless you like cold food.
So, Paul, have you used this to ever deal with systems that have been compromised? So, in this scenario, you need to hackers broke into the machine, compromise it. You can't vouch for what's there.
Burn it.
You need to.
Can't vouch for what's there? Burn it. Burn it to the ground, build another one. You also need to be in a position where you've prepared yourself for that so that you can burn it and deploy another one. If you're curating your servers, you're in a whole world of hurt. You want to get yourself in a position where you can just burn a server and stick another one out there. If you can't trust it, why are you curating it? Why are you touching it? Why are you doing anything on it at all? Flush it down the toilet and put another one in its place.
So, I suppose there that can't redeploy what you just did, because obviously that's been compromised. So
Yep. So yeah, the instance compromised. You can burn the instance and then go back to your automation, your source code, and find out.
so, yeah, that's
Well, no, so that's different.
Yeah.
That's different. Most of all, really speaking to the recovery, but,
Yeah.
Norton will be around to answer more questions, so we're just
Yep,
pressing
no worries.
time. Thank you.
Alrighty, next up. Have another speaker. Alright, so I see a few new faces here. The format of our meetups is pretty standard. We usually have a little intro from the host, and then we have 2 talks, and then we have a section for community announcements. So if you've got any sort of other meetups that you want to talk about, or conferences, or jobs, then after this talk will be your opportunity. And then we'll have some pizza. I did test this.
Oh, damn, Mike.
Is that your pretty little Mac causing a problem?
Nah, it's Microsoft. It's your Windows now.
Sure it is.
Ran fine on my local.
Cool. There we go. So as mentioned, I'm Tim. I'm from Odyssey. This is Boz, also from Odyssey. We've been working with Sportsbet for about 6 months now, maybe a little bit longer. I'm not quite sure. To help them on their journey towards a little bit more automation, a little bit less curation. And actually, when Andrew said he was going to host this, we thought it'd be a really good opportunity to get up and sort of tell what we've been doing with Sportsbet and what they've been doing with us as well. Serendipitously, there's actually a box you'll see in one of our future slides that has Packer in it, but we were going to have to go into detail about what we were doing, but Norton's just done that, so we'll save everyone some time and we'll get through it a bit quicker. Cool, so first up is a little bit about Sportsbet and the environment in which they operate. The betting industry is actually incredibly competitive. Entertainment industry is incredibly competitive. Sorry. It pretty much seems every time you walk down Collins Street these days, there is a new entertainment company out there. I won't mention their names in deference to Andrew. But the other thing is all these companies compete around very specific events like finals or carnivals or World Cups or whatever. That's when everyone is online trying to use these things at the same time. So in this industry, outages are truly terrifying because that's the only time people are using all this stuff. When we got here, we had a new tech leadership team, of which Andrew is one, and there are a few others, who had been brought in very specifically because Sportsbet was looking to roll out, I think it was 7 or 8 new applications across the different channels in, I think, about 12 months, a 12-month period. So they were fairly pressed for time, and they really needed shorter and faster release cycles. The Sportsbet is quite interesting because they own all their own hardware, they manage all their own hardware. They don't really go out to data center providers or cloud at all. Everything is on VMware and sits in one of their 2 data centers, which they own and run. Well, not data centers, but the racks they own and run. Cloud in the short term for them is really not an option because of both the way their systems are constructed, and the entertainment industry is actually very complicated legislatively. So there are a whole bunch of rules about what you can have where and what you can't put in different states and that sort of stuff. So the cloud is scary and difficult. And for an organization of their size, they actually have quite a large number of servers in use. We were a bit surprised when we got here. You'll see how many later. Bearing in mind, there's only a couple hundred people who here. So the first thing we did was an initial review, and what we found was pets, like hundreds or thousands of pet servers running around the place, causing, frankly, mayhem. Every single server that they had was manually updated. They were all curated. The tracking was a combination of spreadsheets, ticketing systems, emails, word of mouth. Back over there, who knows how that server works. Provisioning a new server was slow, in the order of weeks. There were reports of months, but I couldn't corroborate those. One guy said he was still waiting. The testing of those environments, once they did get them, was purely manual. Like, basically, you'd send the spec in, and then it'd come back, and you'd have to log on to the environment and check that all the packages were there, and that they had the right versions, and the right ports were open, and so on. And as you might imagine, that led to some robust discussions between the ops team and the dev team as to what was specified and what was actually built. And the final thing was that local dev environments had very little resemblance to what the code would actually run on at any point in the future. But that also led to a lot of robust discussions, and I did hear the phrase, "it works on my local machine," a couple of times in the first couple of weeks I was here. So we obviously, everyone in this room would be able to say how to fix these problems. My job as a consultant for Odyssey, as a not tech consultant for Odyssey, is to try and help Andrew and the other leads here convince someone to help pay them to fix these problems. Namely getting funding from business, which is always a bit of a challenge. So, obviously, of the 4 things here, we actually have a list of about 30 that we went through with this Sportsbet. These are just the 4 that we're going to talk about tonight. So for manually applying updates, Puppet, it's a very good solution. The way we went and solved that was audit. The entertainment industry is highly regulated. You have to be able to audit and show compliance to that audit. If everything's manually created and you're tracking your system changes to an email or a spreadsheet, it's very hard to audit that spreadsheet or email later. Provisioning being really slow and producing unique results, our value messaging business was time to market is quicker, and total cost of ownership is reduced because if you've got the order of 1,000 servers and they're all running unique flavors of Linux and different packages, you can imagine that managing that is expensive. It takes a lot of time and a lot of effort on people. For testing of the environments, again, we went back to tried and true time to market. It's a great one if you're going to sell something to a business group. They love that one. And morale. We actually found that fighting between dev and ops was getting quite personal. People were not liking each other, and so fixing that was part of what we're trying to do there. And the final thing, local dev environments, Vagrant, lower defect counts and lower delivery risk. Basically, that we can get it right the first time on dev, because it's the same as production and test environments. We'll get through quicker, and our project will run on time. Now I'm going to hand you to Boz, who's going to run you through the actual technical work we've been doing, and I won't speak again until the end. Normal consulting.
Okay. So, as Tim said, we had a problem where we had lots and lots of pets everywhere, and we needed to shoot them down and turn them into pilots. So the first thing we needed to do is design a uniform template which will go on all the Sportsbet VMs. As part of this template, we selected, first of all, an operating system. We selected the CentOS 6.5 Unix distribution because one of Sportsbet's main applications was due to have a new release when we came, and the new release required CentOS 6.5. The other thing we needed to do is determine what's going to be on this template, like what mounts, folders, users, whatever. And to do that, we use the CIS Linux 6 distro benchmark, which seemed like a good fit in order to harden and close the standard operating environment that we're designing. Okay, so after a bit of research, we had a fairly good idea of what it's going to look like, the SOE. We still needed a way to make sure that every VM spun from this SOE will be up to spec in order to up to spec from the CIS benchmark. So we've introduced the server spec suite. We had about 500 tests where each dock point in the CIS benchmark had one or more tests to make sure that we actually follow the benchmark. So we had the SOE, and we had a way to make sure that the VMs span from the SOE are up to spec. And now we needed to implement a way to build this SOE and deliver it to Sportsbet. Okay. I'm gonna go over this slide very quickly because it's very similar to what we've seen in the previous show. We've actually used Packer. We've actually implemented some of the use cases that we have mentioned before. So what we're doing is it's divided to a building process and a provisioning process. The build process, we're using Packer to communicate with an ESX server. We spin up a new VM. we install CentOS 6.5 minimum vanilla ISO. And then using Kickstart script, we download some more core OS packages and start the machine. Once the VM is started, we copy our project's source base into it, and then we start running stuff within the VM after it's loaded up. The first thing we run is our bootstrap script that's supposed to do the initial setup of the machine. Things like setting up an IP, a name, joining a domain, and registering to Spacewalk, which is our RPM repository tool that we selected to use. Once we register to Spacewalk, we install some basic packages we need in order to run our project, stuff like RVM, Ruby, Puppet, Factor, stuff like that. And once we have that, we're ready to actually begin configuring the machine. We run Puppet apply, which is our main configuration management tool. Puppet configures the machine according to our CIS benchmark. And then we run our suite of server-side tests to make sure that everything is exactly as we wanted it to be. Assuming all the tests pass, we run a cleanup script, just as we had before, to get rid of all kinds of things that we don't want in our final deliverable. Stuff like IP, hostnames, working directories, and whatever. That's it. Our machine is ready. We step out of the VM. We go back to the ESX server. We package this machine, and then we convert it into an OVA file, which is our final deliverable. This is what we're going to deliver to Sportsbet and how they're going to spin up new VMs. So this OVA file is published into Nexus. And an interesting note about this building process is that originally this was part of our CI job in Denver, which means that every code change, this process will run and create a new OVA file. But as we began letting more and more people make changes, we realized that it's much too slow. So we created a nightly job, meaning that it will run at night and put into the OVA file all the changes made at that day. Let's take a look at the provision process. It's very simple, very easy. We take the OVA file from the latest one from Nexus. As Sportsbet's personnel would use his favorite client to communicate with vSphere, spin up a new VM, spend a few minutes telling vSphere what kind of a machine it is, how many cores, how much memory, and hard disk, and where to put it. And then once the machine boots up, part of the boot sequence will be our own bootstrap scripts that will take the user to a wizard that will ask the user for all kinds of stuff like what's the host name, what's the IP, what's the domain, what kind of LDAP tools are allowed to log into the machine, and so on and so forth. And that's it. We had a running VM. Everyone was happy. We were using this process quite a lot until one day someone came to us and said, I want to provision 200 machines by tomorrow.
We didn't want to get into naming names. What do you think, Andrew?
Since you brought it up. Okay. So, as simple and good as the process was, we had the deployment process was actually manual. So we created a new auto-provisioning task for multi-servers. This task is using a tool called OVF tool, which is able to communicate with vSphere in a quite smart way. The input to this task is a CSV file, where every line describes a VM. It's very simple to fill out 200 lines. It has two types of params in it. The first type are params read by our task and communicated to vSphere in order to tell vSphere what type of a machine it is and how to create it. Stuff like the number of cores, inventory, memory, hard disk, and stuff like that. The second type of parameters are VMware properties, which the OVF tool is capable of getting and then injecting into the VM.
What allows you to stand on the other side of the screen so the other is talking?
Which means things that have to test. So the second type of parameters are VMware properties, which the OVF tool is able to read from the CSV file and then inject into our VM's file system before it starts. And when the VM starts, the bootstrap script that usually in the manual process asks the user for all kinds of properties like the IP, the domain, and stuff like that, we just pass this XML file and get all the properties from there and just keep on doing the provisioning by themselves without the intervention of the user. Another interesting fact about this process is that while the process is sequential, it goes line by line and provisions new machines. Only the provisioning of the machine within web script, this is sequential. Once the machine is up, then our process starts spinning up a new one, and in the meantime, the first machine keeps on provisioning, like connecting to doing other stuff, whatever it needs to do after the first initial installation. So part of the process is actually concurrent. Okay, so just a small summarize. So we had an SOE, we knew what we wanted on it. We had a way of testing that new VMs are up to spec. We had a good deployment and building mechanism, but originally we designed the SOE to be very hardened and very closed, according to the benchmark. And then as time went on, we kept having to enable more and more stuff on the SOE in order to accommodate for sports-based applications. And basically, we had a lot of changes to the SOE, so we came to realize that we had to have a way to update existing machines that were already provisioned from the SOE. We thought about a couple of ways to do it. One of them was to tear down the old machines and spin new ones up, but it turned out to be too difficult and not applicable with this corporate applications. So eventually we came to a conclusion that we're going to update them using Nexus, Spacewalk, Bamboo, and Puppet Master. I'm going to go over the process of how we did it very quickly. Whenever a code change was needed in the infrastructure code, this code base would be checked out. The changes were done in the code, tested on a local Vegan machine, which we would spin up from our SOE template. And then once the developer was happy with these changes, he would push it to stash. The changes will be picked up by Bamboo, and our CI job would run. The CI job checks for lint, syntax testing, lint testing, and Puppet catalog compilation. And if everything passes, two things happen. First of all, the code will be merged into master, and then in the next 90 build, a new OVA file will be created with these changes, which means that new VM will already have them in them. The second one is this code will be packaged and published into Nexus. And so when we decide that we want to deploy this code into one of Sportsbet's environments, and they have about 10 environments, we would use Bamboo's deployment capability to say, please take this version of code and put it on this environment. And what this task will actually do is take the code from Nexus and deploy it on Puppet Master. And then, of course, every machine out there with the same environment and a Puppet agent will connect to Puppet Master, get new code, apply it. And if this new code required any update or addition of packages or artifacts, the machine was able to go to Spacewalk or Nexus and get whatever it needs. And that's it. That's how we updated our machines. This kind of concludes a very high level of what we did, which is kind of two of the use cases we talked about. A single point that's worth mentioning is that we are using this system in order to provision machines in production as well. As in reference on what you said, this is one of the use cases. And that's it. That concludes the technical parts. If anyone has any questions, you're welcome to catch me later. Oh, now.
Deploying the actual Sportsbet application using the same process, or you have to hold the things separately?
No, so this process we're using in order to deploy the infrastructure code and the middleware. The actual applications is something that we just started a few weeks ago. So there's going to be another one. Yes. It's going to be something very good.
Given these production systems are tech, how do you know you achieve parity with it? It's an unknown state.
What do you mean?
So you bring up a new system to places or custom built one. And how do you know you've got it?
Service spec.
Got
Basically,
Each
it's like unit test. Basically, once you get complete coverage of your legacy code with your new test, you can refactor your code, and if it matches your test, well, you know that you got it right.
on the new system, on the old system, we don't know what
Well, that's the
essential
thing.
and what's
Well, that's the
legacy
thing.
and
You
what's
build your
not.
test to match the old system, and then you build a new one that matches the test, not the old system.
So there's a combination of things. It is a combination of service spec. The other thing is that the test group here are actually pretty far along in terms of automation. They've got a fairly extensive set of application level regressions that do test environment level configuration as well for all their applications. So as we start rolling out these under the application stacks, they use those tests to verify them. That's not hooked into this yet because we don't have the application that flows hooked in. About a third pregnant.
You can't get to a product without having gone through that order. So something you talked about it all was how this helped you with auditing. How did all of this play into that, the audit function that comes from elsewhere?
You're no longer able to make a change on any of our environments without going through Puppet. You can't change Puppet without checking into Stash. Stash requires user login, so we know who made the change, we know when they made the change, and if they're following practice and they put comment code, we know why they made the change. So then we can go and audit that. Yeah, and we've killed all the pets. So
Somewhere, except to the farm.
yeah, the farm, yeah.
The farm for pet dogs.
Yeah. Okay, cool. So that's just the. Do you have another question? Sorry.
If you can't make any changes to our current situation, do you have any cultural issues with changing terms?
We're combating them at the moment. Luckily, we've just got a new tech lead for Sportsbet, who's just joined, who I watched today tell his operations people that despite the fact that there was a server down in production, they weren't allowed to touch the code. They weren't allowed to touch the server unless they checked in code to Puppet. So we're getting there. It was good. It was a brilliant moment for me. I was very happy to see it.
Yeah, that's entertaining. That's a great thing project one.
So last slide, I promise, because that pizza's getting cold and smelling good. Report back to the business on what we've gained. Our server provision time was down from nominally 3 days, although there's that one guy who's still waiting, to about 20 minutes. Environment provisioning time, so an environment was about 20 servers, and they were obviously all got connections. We're down from 14 days to a couple of hours. Production deployment, this was actually a big one for Sportsbet people in the room. Anecdotally, we've heard about 18 hours for some of their deployments, which not all of it was outage, obviously, but it's still a long time to be up deploying code. We're now down to about 3 hours, and I can see the looks on their faces. There's less baggy eyes, and they look like they're alive now on a regular basis. And more importantly, I think this number is a few months old now, but when we last took it, it was about 350 servers were running this SOE and were configured from Puppet and controlled from Puppet. And that number actually goes up daily. Every time a new server is added, it means one of the pets has been taken to the farm. So we're quite happy with that number. When we took this back to business, they were extremely happy with that number. So we're hoping that they will continue to fund Andrew and his team to do more cool stuff, some of which will include the cloud, automating the application deployments, looking it in for testing, and we'll be completely pregnant. A lot of monitoring. If you talk to Andrew later, I'm sure he'll take you down and show you their suite of monitoring screens. It's truly terrifying. And because we're at a DevOps meetup, I think we get shot if we don't mention Docker. So we're looking at it, we promise.
We'll move them to Docker 120.
That's right. And yeah, we're done. So any other questions now? Otherwise, you can grab us over beer and pizza.
We'll expedite this process. Normally we draw this out a bit longer and make it all fluffy. It's on. But we have a community announcement thing. So if you're looking to get a job, if you're new in town, or if you're looking to hire, if there's any cool meetups that you think other people would be interested in, now's your chance. Yes.
We've actually got a couple of opportunities. I work for a cool company called Info Exchange. We have a couple of regulars, which you guys might know, like Sam, from the Ops team. I've got a couple of presentations where we Docker and all, and they're pretty well expected. And we're looking for a couple of Python developers to work in our fully automated Dockerized containerized environment. They've got the DevOps practices. We're having bad stuff going on between the dev and the ops. We pretty much hold hands and go before the I'm the team lead there. So if anyone is community and the not-for-profit sector. We recently won a Google Tech Challenge for development today. Yeah. Well, we got a grant to build a mobile application for the homeless. That kind of stuff.
So he was like, going 75% homeless people in Victoria have a smartphone with data working on.
But they can't, don't drive.
That's as good as telescope data
And more. But yeah, so if anyone's interested, feel free. I'll be hanging around with some pizza and
Great. Anyone else? You're
And hi, I'm Ian from iConnect. To shout out, we've got a couple of roles available sort of from bottom of the stack to the top of the stack. So if you're interested in material construction application, type of SaaS service, we deal with lots of data. Busy day, we could do like 200 gigs uploaded to the system, so it's really busy, lots of indexing, lots of problem sources scales. And as I said, some opportunities at the top end of the stack, right to the bottom of the storage, how do you do that kind of thing, backups. So if you're interested, just go to the website and give me a shout.
Hi, I'm Angus. I co-organised the DevOps Days in Brisbane just recently. We had a bit of stuff up with some stickers. If you came, or you can come with some stickers in the box.
And there's Infracoders stickers as well. So speaking of DevOps, the next DevOps meetup in Melbourne is the 18th of November at the apartment. If you've never been, it's a lot. I said hand wavy at the DevOps meetup, and I got laughed at. It's not as technical as the Infracoders meetup, so if you're interested in more sort of journey stories, that's definitely the place to go. The next Infracoders meetup is the 11th of November, and that'll be at Kogan, which is in South Melbourne. So that should be pretty exciting. We've never been to Kogan before either. So lots of crazy sales and IE tax and stuff like that. Anything else?
Any other announcements?
Yes.
Honestly, you're always hiring. Standard speech. Yeah, so you saw what we did at Sportsbet. We worked with large organisations like Sportsbet or banks or government, implementing DevOps sort of practices, heaps of automation. So if you want to work for us, honestly, come and speak to us. Let's see what you see. There's people.
Just hold you might come
and work with us.
So thank you to come to Infracoders.
That's right.
We just really like
Assimilate.
Yes.
Sorry, just very quickly, obviously, because we've been outnumbered by Odyssey, whether you work for Odyssey or you ultimately I'm looking for you to come down. Start building the team. Big fans of the Odyssey guys, both now and we get forward. We've got a lot of positions this year, next year. There's an actual big focus on growing technology within the business, so we're developers, security, DBAs, we're going to be flavor of no one's man. One day we'll go Yay Cloud.